Hello all. Today we'll try to learn how linear algebra is used in graphs and networks. Okay. See, here they are given a graph network. Okay. The question is find the incidence matrix A, then find the null subspace of A and left null space of A. Okay. N, this is nothing but as left null space, and this is null space. Okay, then find the trace of ATA. Okay, now we will try to find out how the incidence matrix A. Okay, see the given graph is we have 5 nodes and 6 edges. Okay, what I have done, I have taken 5 nodes here and 6 edges here. So coming to first edge, okay, I am considering the starting point as -1 and the ending point is +1. Okay, so for first edge, see here, this is first edge. What I am writing, the starting point is 1 and ending point is 2. So 1 is -1, so starting point I have taken -1 and ending point I have taken +1. So similarly for all the edges we'll do like this. Okay, we'll form a matrix here. So the other way around also you can do it. You can write 6, sorry, you can write 6 edges here and 5 nodes here, no problem. Okay, anything is fine. So here I am considering 5 nodes. Okay, 5 nodes and 6 edges. So coming to here, see for 5, one example I will show you. So 5, where is 5 here? It is here, this edge. It is starting from 4 and ending at 5. So for 4 I am writing -1, starting point I am writing -1 and this is the 1. Okay, so matrix we have found out. If we write this complete matrix, the rest all will be 0. Okay, so if you write in a matrix form, then it forms the matrix, the incidence matrix A, which we are trying to find out. Okay, then next he has asked to find out the null space of A. As you know, null space of A is nothing but as it is the value of x in this equation, in this Ax is equal to 0 form, right? So A we have got it, and x we need to find out by equating to 0. So when this can be 0, see, when we try to multiply by x with this matrix, so we will multiply like this, one row of this and 5 components, sorry, 5 components in the x. Okay, so if you try to see, every row has one negative and one positive, one negative and one positive, one negative and one positive, one negative and one positive. So what is the value of x such that it will result to 0 when we try to multiply with a column vector of x. So it is nothing but as 1 1 1 1, because it already has one negative and a positive 1. So we just need to add it, that's it. So it will become 0. So null space of A is nothing but 1 1 1 1 1, and this is what, 5 cross 1. This is 5 cross 1 form. Okay, this is the null space. And coming to the second question, what is it? Null space of left null space of A. So left null space of A is nothing but as it is also in the form of Ax is equal to 0 form, but only thing is here we will be taking the A transpose, right? So traditionally what you do, you convert this to traditionally you try to convert this to a transpose form, and then again you will multiply by x. Okay, x component, and this will be of form, how much it will be, 6 cross 1. Okay, this will be 6 cross 1. So this is the traditional way of doing it. Instead of this, there is one more way to do in the graphs. Okay, you need not multiply this or try to find out what are the 6 components in this x vector. Okay, the other way is, come to graph here, try to find out the number of loops here. So how many loops we have? 1, okay, 2 and sorry, and the complete whole loop. Okay. So if you travel through this loop, you will find out the one null subspace, and if you travel through this loop, you will find one more null subspace. Okay, sorry, left null subspace. See, in first loop, we'll consider one direction as positive one, and if it is opposite direction, then we'll consider it as a negative one. In this first loop, 1 2 3, what is it? 1 is in this direction, 2 is in the same direction, 3 is in opposite direction. So 1 2 we'll consider plus 1, and the third one is negative 1. See, so this is the, and rest all is 0, because in first loop we are not encountering the other edges. Okay, so rest all are 0. Coming to second loop, what is this one? So we are we will be dealing with edge 2, edge 4, 5 and 6. So 1 and 3 will be 0. See here, 1 and 3 will be 0, and according to direction the values will be -1, 1, 1, 1. Okay, these two are the null subspace, left null subspace, okay, of the matrix A. You need not do traditionally. Okay, this will take more time. You just apply the loops on the graph. And what is the third one? See, third one will constitute, the third loop constitutes both the loops, right? So if you try to find out that loop, it will be nothing but as addition of these two basis vectors of the left null subspace. Okay, that third one will be the addition of these two. So you need not write that. I just told you to understand how to take the how to assign the loops there. Okay, so that is done. Coming to the third part, find the trace of the A transpose into A, right? A transpose into A. This is nothing but as sum of the degrees of the graph. Okay, traditionally you can multiply the A transpose and A matrix and then get the values and find out the diagonal elements, then add the diagonal elements. That is the traditional way of doing it. Okay, trace of the matrix is nothing but as sum of the diagonal entries of the matrix. But in graph you need not do that. You just need to add the sum of the degrees of the graph. What is degrees of the graph? Degrees of the graph is nothing but as, it is the number of edges connected to each node. Okay, for first node how many edges are connected? 2, right? See here, I have written 2. Then for second node it is 3. Sorry, for second node it is 3. For third node it is 3 again, and for 4 5 it is 2 2, right? See, so it is 3 3 2 2, so value is 12. So this is very easy way of doing it. Otherwise, traditionally, if you want to do it your usual way, then you need to multiply this 5 cross 6 and 6 cross 5 matrices, and it will take huge time. And then you need to again add the diagonal entries of those matrix, the resulting matrix. Okay, this will take more time. So, but for these graphs, you can directly use the degrees of the graph to find the trace of the matrix. Okay. Thank you.